Hey math enthusiast, I'm here to go over the notes from section 4.1, which deals with triangle sum properties. First thing I want to do in the notes is define my term triangle. So I know it's a polygon, it has three sides, it has three vertices, in other words, three corners. Now, when I'm naming a triangle, I'm going to name it by the vertices that are given. So let's say this triangle is labeled with the three vertices A, B, C. Then I'm going to call it triangle. I'm going to use this symbol in front, followed by the vertices in any order. It doesn't necessarily have to be in alphabetical order. Next thing I want to look at is classifying triangles based on their sides. So let's say I have these sides. They're all different measures because there's one tick here, two ticks here, and three ticks here. So none of my sides are congruent. In this case, I'm going to describe this as a scalene triangle. No equal sides. The next one, however, it looks like these two sides on the left and the right, they each have two ticks, so they are congruent. So I have one pair of equal sides. This is known as an isosceles triangle. And lastly, it looks like all three of these each have one single tick. All three sides are congruent, and we call that equilateral. Equilateral. Then down below, I'm classifying my triangles based on their angles. Let's start with the second one. It's easy to pick out. I have a right angle, which means that's going to be a right triangle. Well, this one next to it has this large angle that measures more than 90, so it's going to be obtuse. Now, in the first one, I'm assuming that all of these angle measures have different sizes. All right, but all of them are definitely less than 90, so in that case, it's going to be an acute triangle. And for the last triangle, I'm assuming that all three of these angles are the same size. So they all have the same measurement. It's similar to equilateral, but in this case, it is going to be equiangular. So all the angles are equal. For the next example, we're focused on triangle LMN off to the right. First thing I want to know is, what are the vertices of this triangle? As I said, the vertices are essentially the corners, the points that make up the triangle. In this case, it would be point L, point M, and point N. Now, what side is opposite angle M? Looks like angle M opens up to this side across from it, which would be LN. And that's a segment, so I'm going to use the symbol for segment to mark it. Next one I'm worried about is the opposite of side MN. So what angle is across from that side? It looks like it's going to be angle L. I'm going to use the symbol for angle in front of that as well. And then lastly, it looks like we're just looking for another name of this triangle. So initially they called it LMN. I'm going to call it triangle NML. For the next example, I'm going to classify the triangle by both its angles and its sides. In number one, it looks like right away I can see, okay, there's a right angle. So I know I'm dealing with a right triangle, but that's only half of it. That only counts for the angles. I have to say something about the sides. Well, in this case, none of the sides are marked, so I'm going to assume that all three side lengths have a different measurement. So in that case, I'm going to say it's also scalene. So it's a right scalene triangle. For number two, now, as far as the angles go, it looks like we have 75, 75. This angle also appears to be acute, so I'm going to say that it is an acute triangle. And as far as the sides go, we do have two sides that are congruent, which means that it's also isosceles. So acute describes its angles, isosceles describes its sides. The next part of the notes talks about different angles inside the triangle. So we have interior angles marked here in red, which are obviously inside of my triangle. And then we have exterior angles marked here in blue, which are going to be outside of my triangle. Now, notice for the exterior angles, they did not mark this angle, or this angle. The reason being is because this one up top is congruent to this one inside the triangle. It's the same as the interior angle across from it. So the blue angles are the exterior angles. All right, while the red angles inside are my interior angles. So down in this example below, my interior angles would be angle 1, angle 5, and angle 7. My exterior angles would be angle 2, angle 3, angle 4, angle 6, angle 8, and angle 9. Which brings us to our first theorem relating to angles in a triangle. So this is the triangle sum theorem. It deals with the interior angles of a triangle, and it's telling me that they're always going to add up to 180. Following that is the corollary of this theorem. So it's saying if we have a right triangle, so if I know that this angle right here, angle C, is 90, it means that A and B together have to be 90, because those two 90-degree angles are going to equal 180. So that's a little shortcut we can use. For the next example, we're trying to solve for x, and then we're going to classify the triangle by both angles and sides. So it looks like for number 3, right away I know it's a right triangle. This angle on the top right is 2x, the angle down here is x. Now I know if I add all my angles up, so 2x plus x plus 90, together they're going to equal 180. Well, right away I can get rid of that 90, and now I know that 2x plus x is going to equal 90. So this is that corollary that we just saw. If I have a right triangle, I know the other two angles, x and 2x, have to equal 90. Which tells me that 3x has to equal 90, which means that x equals 30. So now I know my other angle measures are going to be 30 and 60. Okay, so I've solved for all the angles. Now I just need to classify it by its sides and angles. So as I said before, I know that it's right, and it looks like none of my sides are congruent, so I know it's going to be scalene. For example number 4, they give me measurements for my 3 angles. It looks like right away I can tell that these two sides are congruent, which tells me that it's going to be isosceles, but we'll jot that down at the end. First, let's add up all 3 of my angles. So we have 3x plus 2. Sorry, we have 2x plus 2 plus 2x plus 2 plus 3x plus 1. Before I set it equal to anything, I'm just going to combine my like terms. 2x, 2x, and 3x gives me 7x. 2, 2, and 1 gives me positive 5. And as I said, I know it's going to equal 180. We'll get rid of that 5 from both sides, which gives me 7x equals 175. And lastly, divide by 7, so x equals 25. Finally, I'm just going to go back and plug this in. So it looks like my angle measures are going to be 52, 52, and then we have 76. So all my angle measures are less than 90, and two are congruent, but not all of them are congruent. So in this case, I know it's going to be acute. It's definitely not equiangular. Not all of them measure the same. It's acute, and as I said, you have two sides that are congruent, so it is isosceles. Next, we have the exterior angle theorem. Now, before I reveal exactly what this is, let's think about what is true in triangle ABC. I know if I were to add these two angles up, or sorry, all three angles, so it would be the measure of angle A plus the measure of angle B plus this angle on the inside, which I'm going to call the measure of angle BCA. So all three of them together are going to equal 180 degrees. Now, what's also true is because these two angles off to the right form a straight angle, I could say that, you know what, well, the measure of angle BCA plus the measure of angle 1 is going to equal 180 degrees because they form a straight angle. Well, if they both equal 180 degrees, I can go on and say that, well, the measure of angle A plus the measure of angle B plus the measure of angle BCA is going to equal the measure of angle BCA plus the measure of angle 1. So now I've taken these two expressions and set them equal to one another since they were both equal to 180. Now, if you notice, what's going to happen is both of them have the measure of angle BCA in common. So what I'm going to do is I'm going to get rid of that. I'm going to subtract the measure of angle BCA from both sides. Those cancel out, those cancel out. Now I know that the measure of angle A plus the measure of angle B is going to equal the measure of angle 1. So these two interior angles are going to add up to the sum of that exterior angle that is not adjacent to them or non-adjacent to them. So for this next example, I'm focused on an exterior angle. So if I take my two interior angles, 2x plus 3 plus 51. If I add those two up, according to my exterior angle theorem, together they're going to equal the measure of the exterior angle that is not adjacent to them. Now that I have an equation set up, I just want to clean it up a little bit. We have 2x plus 54 instead equals 4x plus 8. Now we can move our x's onto one side, move our constants onto the other side. So I'm going to end up with 46 equals 2x. And lastly, it looks like x is going to equal 23. Finally, I want to figure out the measure of the exterior angle. So it looks like if I plug that 23 back in, I'm going to end up with 100 for the exterior angle. And then this little interior angle is going to be 49. So it checks out. If I add up my two interior, 49 and 51, I do get 100. Now for number 6, I want to set it up the same way. Take your two interior angles and add those two up. So I have 103 minus x plus 2x. And together they're going to equal that exterior angle, that non-adjacent exterior angle. Let's simplify our equation first. It looks like I end up with 103 plus x equals 6x minus 7. Move some things around. I'll get this 7 off to the left, subtract x from both sides, so I end up with 110 equals 5x. So in this case, it looks like x equals 22. So now when I take my value for x and plug it back in, it looks like I end up with 132 minus 7, which gives me 125. And then it looks like when I plug it back in here, we end up with 81. And then if I add those up, 81 plus 44, I'm going to get 125. For the next example, we have triangle PRS. First thing I'm going to do is plot my points. And the next thing I want to do is classify it by its sides. So what I'm going to need to figure out is how long are these side lengths. In order to do that, what I'm going to need to do is use the distance formula. So I'm going to take my x and my y values for just 2 points, and I'm going to plug them in here to try and solve for the length of each side. So first let's start with PR. So let's take our x values, plug them in first. I'm going to have 0 minus -1 squared. And for my y's, it's going to be 0 minus 2 squared. So that's going to give me +1 squared and -2 squared, which is going to leave me with 1 and 4, which leaves me with square root 5. Next one I'm going to go after is RS. I definitely expect this one to be longer. It appears longer in the graph. So now when I plug in my x values, we'll have 6 minus 0 squared and 3 minus 0 squared. So in this case, it looks like we end up with +6 squared, +3 squared, which is going to give me 36 plus 9, which gives us square root 45. Now, you could simplify this radical. You could break it down into 9 and 5, since they're factors of 45, which would make it become 3 radical 5. Last one I need is PS. So I'm going to try to clear a little space here so we can figure out what PS is. So we'll take our x and y values and plug them in. Let's go with 6 minus -1 squared and 3 minus 2 squared. So it looks like I'm going to end up with 7 squared plus 1 squared. So we end up with 49 plus 1, which gives us 50. Once again, same deal as before. I can actually break down 50 into 25 and 2, and then square root of 25 is going to become 5. So in this case, it seems apparent that all my side lengths are different. So when I classify this triangle, I'm going to call it scalene. For the next example, we're talking about triangle CAT. So let's jot down what we do know. So I know in triangle CAT, the measure of angle C plus the measure of angle A plus the measure of angle T is going to equal 180 degrees, because that's true for any triangle. So now let's think about each angle individually. So the measure of angle C, the measure of angle A, and the measure of angle T. Well, in this problem, they tell me that measure of angle C is equal to the measure of angle A. So these two are the same. So I'm going to start off, I'm going to call the measure of angle C x. Well, that means that the measure of angle A must also be x if they are equal, if they're the same. Now they go on to say the measure of angle T is 5 more than 3 times the measure of angle A. So I'm going to take the measure of angle A, which I just said is x. So it's 5 more than 3 times that amount. So 5 more means plus 5. 3 times that amount is going to be 3 times the measure of angle A, which is x. Now I have one expression to represent each of my angles. Measure of angle C is x, measure of angle A is x, measure of angle T is 3x plus 5. Now I can go through and try to solve this equation. It looks like we're going to end up with 5x equals 175. So it looks like x equals 35. So now I can figure out the measure of each of these angles. It looks like C was actually 35, A was actually 35, and t was 110. For this next example, I'm looking to solve for all the numbered angles in here, 1, 2, 3, and 4. First thing I notice is that 2 and 58, so the measure of angle 2 plus the measure of angle 58, together they form a straight angle, which tells me they're going to add up to 180 degrees. I could say the same is also going to be true for measure of angle 3 plus 58. That's also going to equal 180. Well, in this case, I can solve for both the measure of angle 2 and the measure of angle 3 simultaneously. Measure of angle 2 is going to equal 122 degrees, and the measure of angle 3 is also going to equal 122 degrees. So the other thing to note here is that angle 2 and angle 3 are vertical angles. So I know that they're going to have the same measurement regardless. So we'll try to fill this in our picture. It's really small. So those two are congruent. Now I just want to focus on the top triangle because we have the measure of angle 1 plus 22 off to the right, and then the 122 that I just solved for. Those angles together, they make up a triangle, so they have to add up to 180 degrees. Then I know, well, the measure of angle 1 plus 144 equals 180. So now I know the measure of angle 1 is going to equal 36. So we can fill that in, 36. Got the measure of angle 2, that's 122. The measure of angle 3 is 122. Now down to my bottom triangle. So down here we have the measure of angle 4 plus 20 off to the left plus 122 equals 180. So we end up with the measure of angle 4 plus 142 equals 180. After I subtract that 142, it looks like the measure of angle 4 is 38 degrees. For the next example, I'm trying to solve for x and y. So let's focus on this triangle off to the right. So it's made up of 3 angles. We have the right angle in the corner. I have the 39 up top, and y. Well, I know together they're going to equal 180 degrees. Well, it looks like we're going to end up with y equals 129, or sorry, y plus 129 equals 180. So now it looks like y is going to equal 51. Okay, so that one wasn't too bad. Now I got to figure out how to find x. So I know this is 51 in here. One way to go about it is to focus on this straight angle. So I know all 3 of these angles, and we'll call this angle z, I guess. So the measure of angle z plus 50 plus 51 is going to equal 180. They form that straight line which has 180 degrees in it. So now I know the measure of angle z plus 101 equals 180, which tells me that the measure of angle z is going to equal 79. So now I can fill that in, and that's going to help me to get to x. So now I can focus on this triangle on the left-hand side. We have x plus 56 plus 79 equals 180. So we have x plus 135 equals 180. So it looks like x is going to equal 45. The other thing you could have done is used exterior angles. So I would have known that these two interior angles, 45 and 56, together are going to add to this whole entire exterior angle, which would have been 50 and 51, which is true. It does work out. Number 11 is very similar. I'm trying to solve for x and y. First, let's focus on this triangle with the right angle. So we have 90 degrees, I have 31 degrees, and I have that other angle, which is 4x minus 1. Together, they're all going to add up to equal 180. Well, let's combine some terms here. We end up with 4x plus 120 equals 180. Get rid of that 120, so I end up with 4x equals 60, and it looks like x equals 15. Now that I have that solved, now I got to try to focus on the y. Well, if you notice, these three angles together form a straight line. So I know that 65 plus 31 plus 2y is going to equal 180. So it looks like I'm going to end up with 96 plus 2y equals 180. And we end up with 2y equals 84 and y equals 42.